Okay, basically what I've had to do is mute everyone because there are too many online, and questions can be raised through the support at the Steel Detailer email address. That will ensure that any questions that you want will be covered thoroughly. Today's topic is about driving sketches and what purpose they serve within the Steel Detailer's functionality. Um, Basically what I want to cover is SolidWorks functionality and also TSD functionality in the same process, because the TSD functionality works with SolidWorks functionality. Driving sketches are very crucial to the way SolidWorks operates and the way that we detail steel and use steel in models. So this little webinar should take about 30 minutes. And should cover pretty much most of anything to do with driving sketches and how SolidWorks works. Now, I've just had a little bit of technical difficulties earlier, and I'm just going to have to fire up SolidWorks again. Meanwhile, there are many reasons why we need to use driving sketches. Driving sketches themselves can drive a whole project quite easily. Now I'm going to just go into the basics of a driving sketch to start with, so you can see what goes into a driving sketch, and then we'll go through all the different types of driving sketches. So I'll just get that up nice and big. Now I've just logged into an area that is a tutorial area that you get with TSD when you wish to trial it, and basically what I've done here is I've just put a point on the origin as a start sketch to insert a driving sketch on. Now TSD comes with in the tutorial library a driving sketch frame to which you can use, and I'm just going to show you what that's all about, and then all the other different types of driving sketches. So going to the TSD members area, and we can go into frames. Frames can be driving sketches as well as driving sketches can be frames. It's up to you on how you want to label them and how you want to place them. You'll notice that I've got different types of frames in there that I can attach to. Frames or driving sketches, it's up to you. So I'm just going to pick the single sketch point, and I'm going to put a frame in on that sketch point. And sometimes if you don't get action straight away, like this instance, is you've got to do a rebuild and then a save, and then we'll have another go at it. Alright, so there's a frame that's gone in. Okay. Now TSD, when you actually insert a frame, all it is a SolidWorks model. We've got an assembly and a part. Now any driving sketches that need to be named, we usually call them a dummy part. So the third letter that forms the part here from the right is a D, and what we also do with driving sketches is we exclude them from the bill of materials, which means that when we do a BOM at the top level, we don't want our driving sketches coming in to influence that outcome, so we just turn it off so it doesn't come in at all. You could do it at the top level assembly and turn that off as well, so that doesn't come in, because you might want to put more driving sketches in here, and that just turns it off. So I'm just going to save that now. So this is a driving sketch, and you can see what's been put together. Now some people like to model 3D sketches. I have a personal preference for 2D sketches on planes. The reason I go 2D sketches on planes is because if something falls over at a higher level in the tree structure, I can go back up the tree and modify it easily. Whereas with a 3D sketch with structures, they can get a little cumbersome, and when you go in there and you change something, it can be harder to repair. There's a lot more work involved. That's obviously personal preference. It depends on what you're used to using. For me, I like planes, and I like sketches on planes. It just makes it easier, because then I can adjust planes. There is some limited functionality with planes in 3D sketches. So looking at this setup that we've got here for this sort of frame, if you go through it, it's just basic SolidWorks functionality. I've created a basic grid, which is just a couple of lines snapped to an origin. I then have a plane that follows that as we go through. Grid 2, Grid B, you don't see those, but if you zoom right in, they're right down low. That just sets up some planes so that I can put some sketches in. I then have a floor sketch and then a stair offset. which drives the position of where I want my stairs. I then have a stair center plane which runs on that little sketch line that's there for the stair, so I can insert a sketch frame. I then on my south column sketch put in a couple of lines there to get the columns and the bracing and so forth. So basically all it is drawing sketches. There are some rules that you have to follow. The rules that following in TSD for snapping onto is that when you draw your driving sketch, you have to ensure that the lines that you are drawing are going in a certain direction, because what happens is when we go to put a member on to a driving sketch and snap it on, it will stretch from the start point of your sketch in the direction to the finish point. So say for instance I'm going to put a column on these two lines. If I have the line drawn from the origin at the bottom and to the top, it means that when I snap my column on, it's going to stretch from the bottom to the top, because I've actually drawn a member sketch in the member that will stretch in that direction. So you've got to really ensure that you draw your member sketch in a certain way so that the snapping directions actually work the way they should. What I mean by that is, and I'm just going to show you, under the members, if we go to the columns, I have to be in assembly, sorry, my fault. It's good that I put this functionality in there because it teaches me to behave well as well. Just going to move that out of the road so I can close that off. So now I'm back in my area assembly, and if I go back to my members and drop a column in, you'll notice that when I put it in, you probably won't notice because it's the same length, but that's okay, because what we can do is we can change the driving sketch. So now if I was to essentially affect the driving sketch itself by going into it and modifying it, I've got level 1, which is driven by that height. So if I change that to 4 meters, I want my column to stretch in the direction to which it should, and if you've noticed it does that. Now if I was to draw a line just off to the side here, I'm just going to show you what can happen. Let's just say we draw our driving sketch from the top down, so it's upside down, right? If I draw it like that and I go to put a member on it, it will insert it upside down. So it's really crucial you get it the right way. And last thing you want to do is have it so that you have to change it. It's a bit odd when you see it like that upside down, but that's what happens with driving sketches. So the rules that we've got is that you want to draw your driving sketch in the direction to which you want it to stretch. Now by default, TSD driving sketch requirements are simply just drawing vertical lines from bottom to top and horizontal lines from left to right. Now that left to right is based on your perspective of the scenario. What that means is that if you look at this line here, which we're going to put a beam on, that line there right round goes in the anti-clockwise direction. Now if I turn the actual model around, depending on which perspective I'm looking at, it goes from left to right. Now if I zoom in on this beam and look at it, it's not going left to right from this perspective, but if you turn it around, it is going in left to right from that perspective. So when I go to put a beam in there, it will snap onto that line and go left to right. And the reason for that is if you actually go into the member, now I've just covered basic driving sketch functionality. Now we're going to go into another different type of driving sketch, and it's called a member driving sketch. So we're going to go into that one. So if we go and open up the column, there is a member driving sketch that's driving this, right? Now this is standard TSD functionality. For every member that we create, we put in the sketch name member sketch, and it has to be written exactly like that. You can set up your templates so that when you go and create new members or new parts, it already has a driving sketch in there ready to go. Some of my customers have already done that. Some of the TSD customers surely understand that having to redo this over and over again is a bit painful. So if it's in your template, when you create a new template, it's already there. All you have to do is just change the orientation of the actual member sketch line. Now when you create a member sketch, you have to ensure that in that member sketch it is the first and only line that goes in. Okay, if you draw a line and then put in a second line, You've got to remove that second line. Okay, if you go in and draw a line and then draw another line and remove the first line, you have to close the sketch and do not save it and recreate a new sketch. It has to be the first and only sketch in the member sketch. Okay, now what's its purpose? I suppose the member sketch itself is what snaps onto the driving sketch. Okay, it is incontextually linked, which means this little arrow at the end here tells me that it is linked right now. And the way that TSD does it is that when it inserts it into the project, it snaps the origin point to which we've set up this driving sketch to. Now the origin point itself is where the member sketch sits. Okay, so it starts from here and goes all the way up in a vertical direction. So the actual stretching mechanism is based on that member sketch. Now I'm just going to go into what TSD does. If I edit the sketch and select the member sketch, you'll see that there is an equal radius and length. Okay, now that equal radius and length is associated to the driving sketch. Alright, TSD does that for us because we picked that sketch to insert it on in the first place. Now I'm just going to remove it and delete it so that now I have a sketch that's free floating. So you'll notice now this is a free floating member sketch. When we model our templates and we want to insert them into the library, we want to have our member sketches floating, okay? Because when we grab the member sketch, we can actually affect the length of our member. And if I drag that down and edit the sketch and drag it down, you'll see that the length changes as I go. This is just a rebuild at this level here. I just do a rebuild, which is a Control Q, and that updates that. So I can actually grab that sketch and drag it in the direction that I want to. So you can see why having a driving sketch at the top level in its direction of its sketch line is important, because the driving sketch that's in this member sketch actually works the way it does. Okay, so I've just broken that now, so that will not be attached to the driving sketch. Now all TSD does, so I can show you, is you edit the member sketch in context, select the line to which is in the member sketch, and select the driving sketch line to which we've attached to, and we just make them equal in relationship. And that's what TSD does. So if you understand that basic philosophy or that principle, you can see that it's really important that we get our driving sketch matching what's inside it. Now I'm going to cover another type of driving sketch setup as well. Now let's look at say a set of stairs. Stairs are really important in the way that they're actually modeled and designed as well. You can have as many member sketches as you like in your member, but the limit to which you can actually snap to is 2. So for a set of stairs, you'll see that there are 2 lines to which we're going to snap to here. If I pick the picture for the stairs and scroll down, I'm going to stick with sketch segment here, and on the object, the very first one that I need to select, which is the horizontal one, as it's nominated here with a 1 and a 2. So if I pick the horizontal line for my stairs and then go over to the diagonal and select the diagonal, I now have 2 lines that have been selected. If you accidentally select these in a mixed order or select the wrong one, just get out of the function by hitting your X and then get back in it again and restart. TSD doesn't know which line you're attaching this to, and if you get it out of order, it'll throw your stairs in. No worries, Cole. It'll throw your stairs in so that it will attach and extend. So I'm just putting some stairs in, and now you will see that the stairs will automatically adjust in horizontal and diagonal lines. Okay, now the stairs themselves, I'm just going to go through the member sketches that are in those. So if I open up the assembly, okay, you'll see that there are some driving sketches in here. Okay, so TSD has attached the member sketch at the bottom, and it's also attached the diagonal sketch, which is what I selected, so that we can have a fix on the driving components of these stairs in the driving sketch above. Okay, now you can have them as many as you like, but once you get past 2, they are manual driving sketches, which you just snap on, like I did in that earlier example of the column. Alright, so that set of stairs is actually driven by the driving sketch. So if I go into the driving sketch itself, let's just say we want to change the height to suit, so we go back to where are we, level 1, and change that back to say 3 meters. If I do a rebuild, you'll notice the stairs will update, because the stairs themselves are driven by what we call an equation in SolidWorks, and the equation determines the number of rises and runs in the set of stairs. Okay. Now you can see how important it is. If I go into the driving sketch of the frame again, and we go in and change, say, the stair sketch, which has got a 45-degree slope on it, and we make that say 36, the driving sketch now controls the stairs. So I'm just doing a rebuild now, which is a Control Q, and you can see that I'm going to have to go in and do a little bit of work on one of the connections that's fallen over. 36 degrees is pretty flat. If you can imagine, it's not within the requirement. There is some compliances that you have to abide by within the Australian standards. I think 36 will probably fit, but it just depends on your rise and your run and how that's set up under the access code. 36 I think does comply, so there's something that's happened to a connection here that's fallen over that should actually work within that range, and that was a good test. But anyway, the driving sketch itself is driven by this process. Now in this instance, I've actually created a singular area driving sketch. Okay, now I'm just going to show you a couple of examples of some other driving sketches that are set up. So I'll just save that. We may need to come back to that again. So if we go in and log into another project, and I've got some other examples here. If I go into a building example, you can see where driving sketches play a part as a single area. Now there are some columns in this, and a truss, and this is slowly getting built as an example to which we're going to give our customers so they can have a look at it. And get some examples from it. Okay, so we've got some columns in here, and you can see that there's a driving sketch frame here as well, which is this one. Okay, and in that driving sketch frame, you'll notice that I've got the DO1 there, and it's excluded from the bill of materials. It's a process to which we follow. And then in here, I've placed everything that I need to know about how the building's formed. I've got my grids, my external edge sketch, which is the building extremities. My grid sketch, which is all my grids that I can familiarize myself with, and then I've got all my planes for my grids. I have my set out sketches, so I have my elevation, which is my driving sketch based on where the eave and the slope of the roof is, and also have my offset distances to set up the steel from the roof, so it creates another frame. And then I have my column sketches, and you'll see that I've broken all these up as I go around. My mullion sketches, which is my end wall columns, my roof sketches, obviously slopes and planes that are associated to that, so if I want to put purlins on the roof. I also have roof purlins if I go down further. There's wall strut sketches, which are these ones here. Girts, in this instance I've turned them off. The good thing about TSD is that if you want to drop a whole roller door in that's inside of a weldment assembly, you can. So you've already got a predefined roller door frame, which you got your stiles and your header in there, and you've got your GP brackets already ready to go, so you can actually do that. I might cover that one in another demonstration another day, but it's fairly quick when you can set that up to do that. So obviously roof purlins, so we've got our purlins across the roof. In this instance I've only done one side because the other side will be an opposite hand process. Alright, so that's just a driving sketch. Now, to create the driving sketches from scratch, there are two different ways. There is a grid function within SolidWorks which will allow you to create your driving sketches, and there's also a basic one for TSD users that we've created, and I'll just show you those so that you can see them. At the moment I'm using this driving sketch, so I'm just going to drop in another driving sketch here and hide this one. To put in a blank part, we can go to TSD parts, and we go blank part. We want to put in a dummy part, and that just drops in a part inside of our assembly, and it somehow picked up the first instance again. So we'll just fix that so we don't have two. It's really odd, that should have been two there. We might have a bug there that needs to be fixed. So what I'll do is I'll just delete that out of there. That's really odd how it did that. Never seen that before. So if we go into the TSD parts again and we want to insert a part, what I'll do is I'll just go in and, sorry, not from the library, blank part, and we'll just put in a member, and then we'll just rename it. So that one there. As you can see, there's always ways around things if there is a bit of an issue. I've not seen that before. So in this case, I'm just renaming this part to a DO2, so it becomes part of it. Now in a DO2, because it's just a single part as it is, we can use the TSD parts and go into grids. Now the grid setup within TSD, you can actually create templates. In here I've got none at the moment, so I'm just going to add one, and I'll just call it a say a 10 by 10 grid, and add that. Now in here, if I tell it what number of grids I want, so I want 6, I want a length of them at say 6 meters, and then I can go add. So these are horizontal grids. I can change the next one to say 5 meters and then click add, and then the number of floors I want, I can actually change that so that's a 3 for the number of floors and the length, and just add that in there. And if I click save, this saves it as a template so that I can come back to it and I don't have to set it again, and I can reuse it over and over again. There is a bit of work around this that we're looking at in the future so that we can go crazy with different types of grid setups. At the moment it's just a basic grid just to get you started. It doesn't do anything overly complicated, but what it does is it just gets you going. So we click the tick, and then that creates the frames driving sketch parameters. We now need to go around and add our driving sketches to it once it's created it. So that's now creating it, and that's the sort of crazy sort of behavior that it does so that you can go in and go nuts. So it's created the 3 floors, and you can see that there are 3 planes in there, and it's given us the grid. So if we look at it in plan, so it's set it up for us quite quickly. So that can be of use to you for the basic setups. So if you just want to do one grid floor set out. Now it leaves it open, so it means that you can go in there and put as many dimensions as you like all over it and modify it as much as you like, without having to undo most of the work. So it's actually left it open for you to run amok. Alright, so that's the TSD one. The SolidWorks one is a little bit different. I haven't done this for a while, so I just use the basic grid that's within TSD. Insert, I think it's, as I said, it's been a while. Sketch tools. Oh, come on, my laptop only lets me see so far. Yeah, I don't think I'll cover it because I can't remember it exactly how it's done, but you can actually insert reference geometry and then a grid system. There we go. So you actually start drawing your grid here, and over in the tree there is a way of doing it. So I'm just going to show you how that works. I remember some of it now, it's come back to me. So if I just draw a basic grid, it can be any shape or form. Just make sure my lines are horizontal. Okay, and now I've got myself a grid sketch. I can now go in and insert my reference geometry grid system. So you get a little bit of an interface here on the left hand side that will allow you to create different floors on that grid that I've just created, and you can auto number balloons and stuff like that as well. So there's your grids. You can see I've actually drawn that quite small, so it's not come out very well at all, but it gives you grid numbers, so you can actually work with the grid numbers, whereas the TSD one, we haven't built it in yet, but the possibility is there for us to use it as we go further down the track. Now if you want to know more about grid numbers and grid setups, sure, send us an email at support at the Steel Detailer, and we'll ensure you get an answer for what it is that you're looking for. SolidWorks itself does not put grids in drawings. You have to manually add them in. It's a bit of a pain in the butt, but once you've done it, you've done it. These grid numbers here in this grid system come into your drawing, whereas the TSD one doesn't, because we haven't set it up yet to do that. So there is a benefit in both. It's up to you on how you want to handle them. Also too, it adds a feature, so you can go in and modify that feature to suit yourself. Alright, so that just covers some basic processes of creating some frames to start with. Okay. I'll just close that off. Actually, I don't want that anymore, so I can just remove it. And when you do remove a file out of SolidWorks, just make sure you go and remove it from the system. Whoops. So that they're not in there anymore. Oh yeah, before you do remove things, just make sure you do a Control Q and a Control S, just to remove it, so that it doesn't stay in memory. Okay. It just tells SolidWorks that you've disconnected from it. Okay, so now I've covered the driving sketch and how we can create a basic driving sketch. The purpose of the driving sketch obviously is to snap our members to the driving sketches so that we can manipulate them through a parametric behavior. So that's that particular type of driving sketch, which is a one building driving sketch. Then there's other driving sketches for multi-user environments, which I'm going to show you now, which is quite different to what I've just shown you. Now if we go into the project which I've got for mining, which is this one here, I have a driving sketch in the top level assembly, so I'm just going to open this one up. Now this has got models in it that have come from another package. They are very large models and they are speed packed. I'm just putting them in as examples just to show you that you can link models together. Now, being really large models and then opening this up as quick as what we do is something that SolidWorks allows us to do, which is really good. These models themselves are quite large, and I've got several of them in this project. You know, you can sort of see what's in them. Now they were modeled using Tekla structures, and we've just brought them in to model around them. Okay, so yes, you can bring in models from Tekla structures. They have no smarts, but they are there for us to work with. We also can bring in Tekla structures models that have smarts through SDNF, or even through what's our analytical packages, STAD-Pro. So there is that way as well. So I'm just going to get into the driving sketch that you can see here. Okay, so this is what we call a top level project assembly. If you attended last week's webinar, you would have seen a project top level assembly, and you would have seen how that's been created based on different areas. So in these areas, so the last project we did cover was just one area. In this case there are several areas, and in each area we have the driving sketch, including in the top level. So it means that if there's a project lead looking after this project, he can actually go in and change this to suit, and the others will drive. So if I go into a lower level assembly, which is where everyone will work, there is a driving sketch. Okay. And in that, if I go in further deeper, this is the primary crushing station, and I also have a driving sketch in there as well, okay, which has the conveyor's information. Now the conveyor itself I've put into another area of its own, and in that area anybody can go in and model. So that's the idea of it. So it has its own driving sketch inside it, and inside of it we have a conveyor that we've got as a member, and in the member you'll notice it has two member sketches to attach to the driving sketch. There's obviously a horizontal and a diagonal that we've used, similar to the stairs. Now inside this there are driving sketches that are being also used, so you can in your weldment members create driving sketches and use those as well to attach other things too. So you'll notice that inside this conveyor that's come in, there are profile sketches, there are module sketches which we can attach our gantries to, and then there are trestle sketches, and that's all come in with the member. So you can provide driving sketches inside members as well, in weldment members, to attach other things to. That's available to customers if they want that. And that's another way of providing a driving sketch. Now I'm just going to show you that with this driving sketch at this level, when I open it up, I've got different sketches in here, and I've actually got them all hidden, so I'm just going to turn them on so you can see what I'm doing, and do those and do those. And you'll notice that through my driving sketches I've set up my belts, and I'm also driving the position of my structures from those driving sketches. Okay, now this might throw a few people. Some people just want to do one building or one structure in an area, that's fine, but this is for those that want to use a multi-user environment and have a driving sketch big enough to change a whole layout of a project. Okay. Alright, so that's just an example of what you can do, and you'll notice that my structures are there. I can drive the position of these structures by changing my driving sketch at the top level. So if I've got people working at lower levels, they've got those assemblies open, I open up the top level assembly and I change the driving sketch, they will be notified that there is a change that has occurred, and they will ask you if you'd like to update your model, and the position of your structure inside your project will move. And then you will continue on working. Or alternatively, you can have some changes that will change your structure at this level. And that could be positioning, not just positioning, but you could also set up your grids for your major structure in the same driving sketch part. So you might have a grid here and a grid there to drive your structures. I personally would prefer to have separate driving sketches in the areas. That way you can modify or manipulate the driving sketch if you're in control of that area. Generally, if there's a major driving sketch at the top level, it's for positioning, and that's how I usually set up a driving sketch for a multi-user environment. If you've got any questions around that and it probably seems a little ambiguous to you, please just ask. This has been set up so that we've got a team of people working on a project, and we don't want to influence each other too much. And changes that occur to a plant layout, you just want to make sure that they don't change that much. So what happens is the driving sketch itself is made read-only, so the only person that can get access to it is the project lead, and everybody else is just working inside their lower level assemblies, like this one. Okay, so that pretty much covers the driving sketches types. Now we're going to go down into connections, and I'm just going to show you what actually happens with member sketches in connections. So we're going to go back to the tutorial where we've got the column. I'm just going to log into that area, and in the column we've actually got some driving sketches in the base plate. Now these driving sketches are member sketches. So if I open up that column, I'm just going to do a rebuild on it to remove the red, and I go into a connection at the base plate. Alright, you'll notice these lines sticking out. These are member sketches, and if they are floating, it generally means that they have to be snapped onto a driving sketch. Within TSD, we use the member sketch to let people know, or customers know, that they need to be locked onto something for them to be driven. Okay, when we create these sketches, they're there for a purpose. Now, as a member sketch inside a weldment member is driven, so is a member sketch inside a connection. So it's important that you also connect these to a driving sketch. And it's just a simple process, as this is a manual process at this stage. So I'm just going to go back to the top level assembly. I've got cleats here that I don't want in this scenario, so we've just provided extra cleats for bracing to make it an all-rounded sort of a connection. And then all we do is just simply hide what we don't want as far as the driving sketches go. And now we've got sketches that we need to snap on. Now to get to the connection, I usually click on a plate. That makes it easy and exposes everything in the tree. And now you can see the member sketches that I have. Now I've got one here that I don't want, that I forgot to select, and I'll just hide that. Now the ones that are blue here need to be snapped on. And a manual process of snapping is to just edit the sketch, select the line, select the driving sketch, and make them parallel. So now that one's going to lock on. And you'll notice now the driving sketch has got its in-contextual reference. Okay, same sort of scenario here. If I grab that member sketch there and that driving sketch line and make them parallel, now that whole connection is driven. So it means that if I was to change anything as far as the floor slope goes, let's just show you how this works as well, because I'm just going to come on and do a side view to it. If that changes, if the driving sketch changes, that cleat will automatically update as well. So if I go in and I double click on the level 1 again and change that to say, now I'm just going to throw this right out so that you can see the change that occurs. Now it obviously will not come down to a meter, but because it's snapped on, everything updates, including the cleat. And obviously in this scenario we've gone past the clearance boundary, so we'd have to go in and modify the cleat by editing the sketch that drives it. So in this case I've just selected that sketch there, and if I actually do edit the sketch, my clearance is on a vertical. For me to change it, I just delete the original, pull out my cleat. As you can see, it drives it, and that'll drive the plate once I do a rebuild. And I'm getting a little off topic, but you can see here with the driving sketch of a plate, because that's another sketch type, I can change the position of the clearance, which means now my cleat automatically updates to suit that scenario. Once you've built it, it's easy to modify it. You've got to understand the processes, but the connections themselves have driving sketches, and they also have sketches to which we can modify to allow certain changes to occur. So now you can see how sketches influence the process, and you can see that column is updated because of the 1 meter height that I gave it. So for small platforms and things like that, you can actually reduce this. It's quite an interesting process, but you can. And the stairs themselves, looks like that piece has fallen over there. Maybe it might need a rebuild. And it looks like I've got a bit of a pause happening here. I'm not sure exactly why. It might be graphics because I'm recording screen and sending screen at the same time, so I'm getting a little bit of lag. So that pretty much concludes the driving sketch processes here today. If you've got any questions, please send them to support@thesteeldetailer. And I want to thank you for your time, for sitting here and listening to me for the last 40 minutes. And yeah, enjoy the rest of your day if you're going on for the rest of the day. If you have any questions, support@thesteeldetailer. We've got a team of people there that can answer your questions, and hopefully this will alleviate any questions around creating driving sketches. Okay, so thanks very much for your time.